Okay. Good morning, everyone. I hope you're enjoying the OpenStack sessions which are going on. I'm going to today talk about the quality of service for the OpenStack storage, and the focus is going to be more around like what we do in Cinder and how the quality of service can be brought in for the instances and the volumes which you basically spin up all the time for your projects and the tenants and the users in the OpenStack, and how dynamically you can change it with a CLI or just a UI so that you can improve the response rate of the projects, you can troubleshoot the latency and whatnot. So quick overview of where we stand and what Tintri does in OpenStack storage. As you can see, we are basically provider of the block storage and can be used for Nova and Glance for ephemeral and the image storage. A standard diagram, this is how we fit in the storage world there. What do? We support all the OpenStack distros. Basically, if you have any DevStack or anything running right now, our driver is upstream in the OpenStack, so you will get it, but we have certified ourselves with the Red Hat, Mirantis, and the HP Helion. And most of the developers which we know in our house, they have been using DevStack also. Another thing where we have seen people use, and the QoS has come very handy for them, is like they're using our storage as a single storage solution for different multi-hypervisor type of situations where it's OpenStack, it is Hyper-V, it is vCenter, XenServer, or Rev, like all of them running in one box, and you are looking at all the instances, VMs, and other virtual machines which are running as in one storage, and then profile it according to your multi-hypervisor environments. What we do is basically we provide configurable QoS for tenants in OpenStack. So as you spin more and more of your OpenStack instances, which are mapped to the users, which are mapped to the volumes, you basically start creating the QoS lanes for them, which provides them the guaranteed performance. How do we look at it? And this is how we approach the OpenStack world if you look at the storage, we have always thought of it as a VM-aware storage rather than looking at the traditional way of just taking storage and then chopping it up into LUNs and volumes and whatever the terminology is. We basically looked into the instances, the VMs, their storage requirements. So our file system has been built according to that. How it comes through, like if you look at the physical data center, the apps were mapped to the bare metal as optimized per workload. It was simple one-to-one mapping. It worked out great. You had the performance and everything given. But with the virtualization, what we saw is like as you are able to move your compute instances and the virtual machines around, storage basically remained the way it is, and it started optimizing for the aggregate load. So you got multiple VMs, you put it in one LUN or you put it in one volume, and then you basically optimize according to that load of the volume or LUN. So any stats you are getting, any QoS you are getting, or anything which you're getting is based on the LUNs and volumes instead of the instance and the VM. So the original concept of app to the storage mapping was lost in the virtualized data center. And what we have done is we have tried to bring it back, and that's what we have excelled on. How do we look at this in OpenStack? As you see, there are multiple tenants. They have multiple requirements. They have multiple demands for their applications, their projects running out there, and they are accessing the storage. And also you have compute and networking, their services being used by storage also. So you have different requirements in regards to the QoS. And why does QoS become important? And this is the slide which basically was presented in OpenStack in one of the sessions, I think so a couple of years back. And what you can see is the use cases for OpenStack. Dev test, we saw it was the most successful use case, and it has been tremendously used. We have seen every type of organization using it. Then production applications, as you can see now, the 69% or 63% of OpenStack clusters are in production environments. And all of them uses database, right? You have MySQL database or you have another database which is fetching data. All of them, what we have seen is requires QoS, and that has been one of the primary questions which we have been getting from our customers to ask for, like, can you tell us more about, like, if I'm running different projects, right, not all of them are equal, how do we do it? And what we do is basically with the VM-aware storage, we basically provide guaranteed lane for every instance and the volume. So depending upon any type of volume you have or instance you have, your developer has given you some requirements in regards to the IOPS, the latency, and the capacity. You basically tune that number in, and that's basically the performance they will get. So for any database sensitive application, you have defined your own instance and the volumes. For any QA test type of environment where QoS is not that important in the multi-tenant environment, your QoS basically limits are more flexible, and all this remains available through the lanes itself. So there is no concept of LUNs and volumes here. It's a direct mapping of your instance volumes, virtual machines, and this can be extended into containers and whatnot also to basically the storage and what is required from the storage itself. How do we do it? Basically, there is a UI which you can use, which comes with our appliance. You have one of the instances most probably running. It has its own IOPS running. It has minimum also there. But what's happening there is because of the IOPS, which is consumed by this tenant quite a bit, other tenants might not be getting as much IOPS they need or the latency they need. So you can just go and drag this line down and then basically set a different max for this tenant, and then let other tenants have their own lanes and their own IOPS which they need. In the same breath, you can basically give them a minimum also. Like a person needs a minimum amount of latency bandwidth for its application to be successful, for customer experience to happen, and you just drag that minimum line to the upwards, and then you provide it. What I haven't shown on this graph is like there is a pop-up box which you get for latency also. And in regards to the latency, what you can see is you will get latency broken down by storage, network, and the host. So as soon as you hover there, you get that information. You will know the latency, where it is coming from. So there is no guesswork for a sysadmin or a storage admin that, is it my storage which is causing the latency or something like that? You just need to tell, if it's instance-based, then you need to tell your developer that there is something wrong in his VM or an instance, and he needs to just fix it. Or you can find, okay, where in network it is causing the problem. This is one of the things which few folks have done, and I talked about it. Like they have created different tiers of QoS for multiple tenants or the projects for their users, and that's how it has been used quite a bit. So as soon as you are getting a couple of apps running up, they predetermined or pre-negotiate the IOPS and the latency requirements what they have, and then they go and configure it. By configuring, I mean they just put in the number for IOPS. That's it. There is no custom script or writing or anything. We provide APIs which you can basically use to put it in your whole orchestration framework also if you want. So that's there too. How simple is it? These are two OpenStack hypervisors we are running. And you can see on the right side where we say hypervisor type. That's what I talked about, the multi-hypervisor manager. Like you'll have OpenStack, VMware, Hyper-V, Xen Server, Rev, all of them listed there. So you can basically start sorting out the IOPS, bandwidth, latency, and how much capacity all these instances are using. So this is basically storage, but it's basically very transparent to the development work, the compute work you are doing. It's not about LUNs and volumes anymore. How do you do it? Configure QoS, you put in the numbers, and that's it. So this is how you do it. And the conclusion is like you can give your instance volume VMs. So that has to be the guaranteed instance performance. So the choice you have is click and configure and automate with the REST API. So you can do any one of them. We will take questions after the session is over. So that's pretty much it. Thank you.